All right, welcome to the lunchtime video. We're gonna keep trying to adhere to the schedule, which is one topic per day. So yesterday we finished a complete topic front to back, and that was Bgp Route Confederation. Not too tough of a topic, so it's really just an aggregation of sub-autonomous systems into one autonomous system. It's a BGP route scaling method that can be used if you don't have a full mass mesh in an autonomous system that is running entirely iBGP. Because for iBGP, you have that full mesh requirement. For eBGP, you do not necessarily have that. So you just create eBGP connections and aggregate them into its own autonomous system, so you can treat them as if they are iBGP connections. So the other method of scaling iBGP is, of course, route reflection. So we touched on that a little bit as well. But we'll be moving on in this video and we'll be doing one complete topic front to back, and this is going to be BGP adjacency formation. So I did this in my 960 videos on BGP. I have a whole BGP series where I studied for version 960 of the exam, but I'm just starting a new one for version 961. And I covered this topic completely, and I think I really did it justice. So fortunately, I don't think I have to be quite as on the ball with this. So if it's kind of incomplete, moves on too fast, don't get a good sense of it from these two videos, go back to those other videos, 961, and I think it'll be much more in depth and much better. There might be issues with the audio and all that sort of thing, so I apologize for that. But as always, just leave a comment if there's anything specifically you'd like me to look into, and I can certainly just comment on it at the beginning of a video. And if it's anything relating to the test that I'll need to do anyways, I can always change up the order and do that sooner than I had planned. Okay, so now, yep, so here's the first video, and it's going to be for this. Okay. Okay, so there we go. And it's going to be just adjacency formation. So real easy. Let's do the tried and true method. Okay, so we can even just reuse this topology and just look at adjacency formation. So let's go on. Let's start a packet capture between A and B. And then let's go on router A and let's clear the BGP neighborships and take a look at adjacency formation. So I'm surprised there aren't any BGP hello messages. Let's see if the neighborships are currently up. Oh, so it looks like there is one that is inactive right now. So I think I know why, because I forgot to do a write on the Cisco, so it lost its config. Okay, so it looks like the strange bug where it rolls back the last commit happened on this. So it has what I had before I made changes. So we'll get rid of the IP routes, if I may. There we go. And then we'll go router BGP1. And then we'll do neighbor. .172.16.1.2, and then pure AS, remote AS, 6500. And notice we use 6500 instead of 65001 because this is a route confederation. So these sub-autonomous systems are representing, are just collected together, and together they form this major one. So we can just use that. And yep, our BGP membership is up. So we should be learning a route. Yep, so we've got a route, everything looks good. Can see some more detail on this route. There we go, if we just look at it directly. Yep, and we've got tag 6500 instead of 65001. So yeah, let's clear the neighbors on A. So now we've got two inactive. So let's do clear BGP neighbor star. Oops, all I think, yeah. Okay, so now we should see a neighborship form in our capture. Oops, but it looks like it might have stopped capturing, so I'm gonna need to restart that. That's totally fine. That's probably why there weren't any BGP hello messages showing up there, because it had stopped capturing. Okay, so they're still inactive, so maybe we can still catch it. There, one went into established, the other one in established. So yep, looks like we caught it. In any case, I'm going to do it again. So let's just do it again. Oops, so it looks like Wireshark is refusing to open now. So I'm going to stop the capture and then restart GNS. Okay, so now I will restart the capture. Okay, so now it's opening. So now I'll do that clear again. And let's just clear one neighbor so that it makes more sense. So we'll clear 10.0.0.2. Yeah, otherwise it would be kind of a jumbled mess. I mean, it's already going to be kind of crazy, but all right, so very clear what has happened here. So So yeah, let's stop the capture and dig into those packets. So let's take a look at the first here. So we got a notification message with a cease. We've got a hard reset. So we should have, yep, FINAC, ACK, the four-way disconnect. Yep, looks good. Okay, so now we've got a three-way handshake. SYN, SYNAC, ACK, there we go. Aha, but now you can see we've got another three-way handshake, SYN, SYNAC, ACK. So the reason for this is because we don't have one side configured with passive, so they're gonna each attempt to form a neighborship. So you can see this is sourcing from 0.1, this first SYN message. And we've got another SYN message that's sourcing from 0.2. So they're kind of racing against each other to try to form this neighborship. So after the SYN, SYNAC, ACK, we get an open message. And this open message will include specific BGP information, but specifically, it will include the BGP identifier. So that's going to be 10.0.0.1 for this first SYN, SYNAC, ACK three-way handshake sourcing from .1. But the second one here, this next open message is going to be BGP identifier 10.0.0.2 sourcing from .2. So what's going to happen is it will send out this notification message and this is going to be sent from 10.0.0.1. Let's make this a lot simpler here, and we're going to follow the TCP stream just for this. Aha, so now we can see much more clearly that I got the open message, it got the BGP identifier 10.0.0.1, but then something interesting happened. It gave out a notification message, and we got this connection collision resolution minor error code. And then after that, we got a FINAC here. So it closed connection rejected, and then FINAC from the other side. So from 0.1, 0.2, 0.1, we've got the handshake message, then 0.1 sends out a open message with its BGP identifier, then 0.1 sends out a connection resolution message, and I believe what this will say is I have the lower BGP identifier, therefore I commit to stopping this handshake. Is that okay with you? So now we've got .2 here. We just got some TCP information here, but it doesn't seem super relevant. But 2, it looks like we've got another ACK from 2. Doesn't seem super relative. So 2 will send out an open message, a notification message saying, okay, yeah, that's totally fine. I have the higher router ID. I have .2, you have .1. So it's totally fine for you to resolve this connection collision by shutting down your attempt to initiate this connection. That is fine with me. So I will send you back a notification message that says connection rejected and not allow you to continue on. And here's the FINAC. You're not allowed to create a session because I will do it because I have the higher the higher BGP identifier. So now we can see from the perspective of router 2, SYN-ACK, the three-way handshake for router 2, we've got that same open message starting off. So we've got a higher BGP identifier. Yep, and now we get an open message back from 0, 1 because this one is allowed to continue. There's no extra steps, and now we've just got our keep alives. We've got our updates with our NLRI, so our routes that we want to participate in it, and everything goes on its merry way because this has a higher BGP identifier. We'll go back and look at the other one briefly. So here's the open message as a lower one. So it sends out a notification. One thing I'm a little bit curious about though is how can it tell that it has the lower one? Like how can it see the other side and determine that it has a lower one? I'm curious about that. Yeah, I'm curious about that. I don't know. Because it didn't receive anything back. It just said, like, oh, this is just extra capability. Yeah, that's not going to be what I'm looking for. Yeah, I'm just wondering how it knows that it's got the lower BGP identifier. I mean, it must be the SYN-ACK, right? Because that's the only communication it has from the other side. Maybe it's like a TCP option. Could be in IPv4 header. I mean, we've got the source and destination, but that's not always necessarily the BGP identifier. So I think it might not be based on the BGP identifier, or it might be based on the source and destination address. I mean, we can test that by changing the BGP identifier to be lower and see what happens. Yeah, I think I'm curious enough to do that. So what we're going to do is go over to router A. We're going to take a look at show BGP group. So we've got a route identifier listed here, I think, unless I need to use a different command. Yep, I will. Okay, so I'll use a different command, show BGP. Summary. How do I see what my router ID is? Yeah, I can't see what my BGP ID is. maybe show IP BGP. Okay, well, I can't see that. Let's see if I can just configure it. One thing I might be able to do is do edit routing options. Yeah, set router ID. We're going to set it to 10.0.0.0. So now this is going to be lower. Oh, we've actually got to set it to be higher because if we go back to our Wireshark capture, we can see that the lower IP, this one, when it's initiated from that has the lower BGP identifier. Yep, it's gonna back off. But going over here, the one with the higher BGP identifier, it's going to not back off. So let's set the one that was originally lower to be higher and see what happens. Okay, so now the one that was lower is going to be higher. Okay, so we'll need to make sure our capture is good to go. So I will delete this one. It'd be nice to have them side by side. So I'm going to save this on my desktop and say router ID example. Save. Okay, so I've saved that capture, so we pull it up again if necessary. So now I will start the capture again. Yep, open up the capture file, come over to router to A and do the clear command again. Okay, so it's time to hit that command. There we go. That looks pretty easy. Okay, so let's see how this one is different from the other one. Yep, we've got our notifications, we've got our keep alive, so looks like everything's complete. So I can stop the capture. All right, and let's follow the TCP stream for this first one. Okay, so now we can see it's quite a bit different. Let's open up the other capture. Oops, so it looks like, okay, no, never mind. So yeah, and then let's follow the stream. So perfect. Okay, so here's the one sourcing from that one with the hello. So let's put these side by side, make it really clear. So when I changed the router ID so that, then let's take a look. Yep, so now the BGP identifier is .3 because I added the router ID. Now this is going to win because the BGP identifier of the other one is still .2. I didn't change it, so this is now lower. So you can see we've got the notification message that it's going to resolve that connection collision. Then the other side responds back saying, oh, okay, that sounds good to me. Okay, well, let's go a little bit slower here. So yeah, we've got the open message, then we've got the notification message. I'm going to solve this collision. And that answer of how does it know what the other side is because it can read these the other packets. Like it's seeing stream 1 as it's processing stream 2. So it's seeing both streams. It can read information from the other stream and apply it to this stream. So that's what's going on. That's how it knows to send out this notification message, because 2 streams come in and it's reading both streams and saying, hey, there's an issue here when I'm reading these both streams. They seem to be attempting to do the same thing, which isn't going to work. But I see that this one stream has a BGP identifier that is lower than this other stream. So the one with the lower one sends out this connection resolution message, and then sends out the and then sends out the fin app. The other side also sends out a connection collision resolution. So I hope that's as clear as it can be. I've got a little bit of extra time just because I'm so comfortable with this one. So you can see very clearly this one with the ID in the open message of being .3 goes through, but on this one here, when the ID is not adjusted and it's .1 and it is lower than the ID of the other router here, which is .2, then this stream gets severed. But in this case, when it's got a higher router ID, it goes through fine. So I hope that's nice and clear. Let me know in the comments if I need to make it more clear. I don't know how I would do that, but I can try. One thing I will do next is go into edit protocols, BGP group, and then Bgp Set Neighbor 10.0.0.2. Okay, and then I'll look at all these extra options, because I think these are going to be, a lot of these are going to be really important to know about. So I'll just read the options. So here's the really the one that will help with the issue we're having here is this passive. So I'll enable that. Okay, and then I'll start another capture, and we'll see how things look. They're going to look a lot nicer, so we'll see that. Okay, and you just put that passive on one side. It doesn't really matter which one, but having it is much better than not having it, as we will see shortly. So that all looks the same, but shortly we will see that when it reconnects, we don't have any of those ugly red packets. We don't have two three-way handshakes going on. We've just got a much simpler and more streamlined Wireshark capture. There we go. So, yep, you can see we've only got one handshake now, sourcing from the router that was not made passive in its neighborship connection. So it doesn't matter that it's the lower BGP identifier now, because that other one isn't going to initiate the connection. It's just going to passively sit and wait for a connection to be initiated. So yeah, let's take a look at how much nicer this one looks versus the other one I have saved. So let's go back. Yeah, so it's jumbled mess with all kinds of colors. We've got a red packet, black packets. But here and the other thing, we've got disjointed hellos. ISIS snuck itself in there. We can't tell where one stream begins and the other one ends unless we filter it out. But here it's all nice and pretty. So lots of value in using that really kind of critical command if you want to have a really good grasp on what your traffic is doing. I'll probably end up using those during the test. I'm not sure. I'm not sure what's going to happen during the test. I mean, I don't know what they're going to give me. I still don't even know if I can take it, to be honest, with everything that's going on. But yeah, let's look into some more of those options. I'm kind of grasping at straws here because I feel pretty confident in this topic. I did it justice in my other series, I think. Okay, so let's just read all of the options. So we've got accept remote neighbor, allow import policy to specify a non-directly connected next hop. Then we've got add path display IPv4 address, display add path, path ID in IPv4 address format. And we've got advertise BGP static, advertise BGP static routes, advertise external, advertise best external routes, advertise inactive, advertise inactive routes, advertise peer AS, advertise routes received from the same autonomous system, and then just regular old apply groups for everything. We've got AS override, replace neighbor AS number with our AS number, authentication algorithm name, authentication key, MD5 authentication key, authentication keychain, keychain name, BFD liveness detection, bidirectional forwarding detection, BFD options, BGP error tolerance, handle BGP malformed updates softly, BMP, specific settings to override the routing options settings, cluster identifier, damping, enable route flap damping, description, text description, egress TE, use egress peering, traffic engineering, enforce first AS, enforce first AS in AS path is the neighbor's AS, export policy, family, protocol family for NLRIs in updates, forwarding context, routing instance used for data forwarding and transport session, Graceful restart, BGP Graceful restart options, hold time used when negotiating with a peer. So I'm going to take a note because I think there are some things they'll test me on. Notably, I think Graceful restart will definitely be on there. So I just want to look into that further. And then I also think BFD is going to be on there as well. Yeah. Okay, hold time used when negotiating with a peer. Idle after switchover, stop peer session from coming up after nonstop routing switchover. Import policy, include NP next hop, include next hop attribute in multi-protocol updates. So I think we're going to need to look into this as well. IPsec-SA, IPsec-SA name. Keep, how to retain routes in the routing table. Local address, address of local end of BGP session. Local AS, local autonomous system number. Local interface for IPv6 link local eBGP peering. Local preference, value of local path attribute. Log up down, log a message for peer state transitions. Metric out, route metric sent in MED. MTU discovery, enable TCP path MTU discovery. Multi-hop, configure an eBGP multi-hop session. Multi-path, allow load sharing among multiple BGP paths. No advertise peer AS. Don't advertise routes received from the same autonomous number system. No aggregator ID. Set router ID in aggregator path attribute to 0. No client reflect. Disable intra-cluster route redistribution. Out delay. How long before exporting routes from routing table? Outbound route filter. Dynamically negotiated cooperative route filtering. Passive. Do not send open messages to a peer. Peer AS. Autonomous system number in plain number or higher 16 bits, lower 16 bits. AS dot notation format. Preference value. Remove private. Remove well-known private AS numbers. RFC 5610 compliant SAFI 129. Compliant with RFC 5614 SAFI 129 formats. Route server client. Enable route server client behavior. TCP aggressive transmission. Enable aggressive transmission of pure ACKs and retransmission. TCP MSS, maximum TCP segment size. Trace options for BGP. TTL value for a single hop peer. Unconfigured peer graceful restart. BGP unconfigured peer graceful restart options. So let's hold on to that one as well. VPN apply export. apply BGP export policy when exporting VPN routes. You know what? I wonder in that other, no, because I wasn't even using BGP. But I think this one might be pretty important to know about too. So I'm just going to keep that in the notes and maybe look up, because the next thing I'm going to do, of course, is help apropos on all of these and read some of the help documentation. So I've got about 20 minutes. I've got an after work video too, where I don't know how I'm going to spend an hour on this, but hopefully these topics that I picked out of the question mark for neighbor will provide me with that much content. Configuring graceful restart options for BGP. To configure the duration of the BGP graceful restart period, include the restart time statement at the edit protocols BGP graceful restart hierarchy level. To set the length of time the router waits to receive messages from restarting neighbors before declaring them down, include the stale routes time statement at the edit protocols BGP graceful restart hierarchy level. To disable BGP graceful restart capability for all BGP sessions, include the disable statement at the edit protocols BGP graceful restart. Note to set BGP graceful restart properties or disable them for a group, include the desired statements at the edit protocols BGP group name graceful restart hierarchy level. To set BGP graceful restart properties or disable them for a specific neighbor in a group, include the desired statements at the edit protocols BGP group name neighbor IP address graceful restart hierarchy level. Configuring graceful restart for BGP resets the BGP peer routing statistics to 0. Also, existing BGP sessions restart and the peers negotiate graceful restart capabilities. Oh, okay. All right, let's take a look at what else there was. All right, let's look at this. Graceful restart concepts. With routing protocols, any service interruption requires that an affected router recalculate adjacencies with neighboring routers, restore routing table entries, and update other protocol-specific information. An unprotected restart of a router can result in forwarding delays, route flapping, wait times stemming from protocol reconvergence, and even dropped packets. The main benefits of graceful restart are uninterrupted packet forwarding and temporary suppression of all routing protocol updates. Graceful restart enables a router to pass through intermediate convergence states that are hidden from the rest of the network. 3 main types of graceful restart are available on Juniper Networks routing platforms. Graceful restart for aggregate and static routes and for routing protocols provides protection for aggregate and static routes and for border gateway protocol. End system to intermediate system, ESIS. Intermediate system to intermediate system, ISIS. Open shortest path first, OSPF. Routing information protocol, RIP. next generation RIP, RIP-NG, and protocol independent multicast, PIM, sparse mode routing protocols. Graceful restart for MPLS related protocols provides protection for label distribution protocol, LDP, resource reservation protocol, RSVP, circuit cross connect, CCC, and translational cross connect, TCC. Graceful restart for virtual private networks, VPNs, provides protection for layer 2 and layer 3 VPNs. Graceful restart works similarly for routing protocols and MPLS protocols and combines components of these protocol types to enable graceful restart in VPNs. The main benefits of graceful restart are uninterrupted packet forwarding and temporary suppression of all routing protocol updates. Graceful restart thus enables a router to pass through intermediate conversion states that are hidden from the rest of the network. Most graceful restart implementations define two types of routers, the restarting router and the helper router. The restarting router requires rapid restoration of forwarding state information, so it can resume the forwarding of network traffic. The helper router assists the restarting router in this process. Graceful restart configuration statements typically affect either the restarting router or the helper router. Okay, so now we've got all kinds of relating topics. So I can use my helper. But I think my helper will need some improvements. So in the after work video, and even right now, I'll get started. I think I can use the extra time to improve my helper. All right, so here's my helper. Oops. Okay, so one big improvement I would like is to import sys, and then I want this to be shoot. Okay. I can do search string equals sys dot arg v 1 dot lower. There we go. Now I can do search string. There we go. And then, yep, that's, I think, good enough for now. Eventually, I would like it to be able to go through everything, though. So I'll figure that out in the next video. For now, let's just see if this works. So it doesn't seem to be working. All right. Okay, so that's a lot of that's good to know. So this one was out of range, so I know that. Yep, it goes 0, 1, 2. Okay, yep. So that was good. It's weird that it only allows me. I can't run it with one. I'm only allowed to run it if I give it 2 arguments. But in some sense, that's kind of perfect because I can have it do yeah, search string equals 2, and then I can have search topic equals 1. Yeah. Oops. So now this has a dash in front of it for some reason. Yeah, I need that dash to come out of there. Okay, and I can add a Python tag to this video, but I need to remove this dash. I've got about 5 minutes, so yeah, I won't have any problem filling the time. Okay, so good to go pretty much. Oh, you know what I can do? Let's see here. So yeah, so now I can do that again that I did here, but now I can get help on other things. So let's do OP, help helper, BGP, and then let's add in this. Ah. Oh, I'm missing an I. It looks like it still has a dash BGP, even though, oh, but I cleaned it up after I printed it, so that's why. Okay, but it seems to be working pretty well. Yeah, it seems to be working. I would just like to fix up the code so I don't have to rely on getting the correct topic. I can just search for, if they do this to me, they hang me out to dry by just giving me related topics, but no way to get to them. I can just go like this. Then I can do help helper, OP help helper, like this, and then this word won't even matter at all. And then I can do help, and then that, and they won't be able to hang me out to dry because I'll just be able to find the C also that they recommend. But that's going to be for the after work video, or I figure out how to modify this part of the code so I'm not reliant on that extra variable. And yeah, then I'll probably need to work on memorizing this because I think it'll be really valuable during the test. All right, thanks for watching, and I'll see you in the next one.